Section 8.2, graphing simple rational functions. And of course, you know rational functions are fractions, so we're going to be graphing fractions. So what we're going to start with is, let's start with the parent function. Always when we graph, I like to look to see, well, what shape are we looking for? When we're dealing with a fraction, the parent function of just y equals 1 over x is going to be what's called a hyperbola. It's two swoopies. So one's going up and one's going down. The domain is all non-zero real numbers. The asymptotes are x equals y and x equals 0 and y equals 0. So we're going to go right up to the x and the y axis, but we're not going to cross them. And because that's because if x is 0, then that's an undefined amount. So we can't actually go to the 0, but we can come right up to it. So this is what your parent function is going to look like. So anytime you just have a number over x, you're going to have the same domain. It's going to be all non-zero real numbers, and the asymptotes are going to be x is 0 and y is 0. So let's do one here. If y equals 4 over x, all you're going to do is you're just going to plot some points, and you should recognize, ooh, this is a fraction, therefore it's going to be a hyperbola, and so kind of have an idea of what it's going to look like. So 4 over negative 2 is going to be negative 2. 4 over negative 1 is negative 4. 4 over 1 is 4, and 4 over 2 is 2. So then just plot those points. Negative 2 is here. Negative 1, 2, 3, 4 is here. And 1, 4 is up here. And 2 is right here. And then if you want to plot some more points, you can. But because you know this is going to be a hyperbola that gets close to the zeros, you can just kind of put a, oh, looky there. Oh, that one's kind of not very smooth, but that's okay. And then this one goes, oh, let's see which way, up or down. There we go. So there we go. There's your hyperbola and you're done. So your domain and range, because we haven't changed this fraction at all, the domain and range are still both all non-zero real numbers. So we can't get to 0. We can't go to 0, but other than that, it's all real numbers. All right. The next thing happens what if we, now we're not going to always have some number over x. It's not always going to be that easy. So of course we have to make it harder. Translations are what's next. What if we have the sum number over x minus h plus k? So in this case, what happens is this a over h is still the parent graph. That's still the main part that we're talking about. And of course, the h and the k are going to shift our graph to the right and up, or to the right or left, and then up and down. So the h is the right or left shift, and the k is the up or down shift. What that shifts is the vertex, the middle of our hyperbola. So it's going to shift where those asymptotes end up. So what we can do is the asymptotes are where x equals h and y equals k. So the first step when you're graphing this type, the first step is just to draw in your asymptotes. Once you've got those asymptotes, then you're going to plot several points. You're going to do the same type of thing, pick points. And pick points wisely because you're going to have a fraction here. So pick points that make your fraction easy to work with. And so plot several points so that you can see generally where is that going to lie, and then draw the hyperbola. I didn't show you here what I was going to do. Yeah, I just didn't mention. Let me back up just a touch. Because as we multiply this by 4, you can see that the hyperbola gets further away from the origin. So when it says, what does this do? Explain what happens. Compare it to the parent graph. It's moving as you're multiplying your numerator. The hyperbola moves further away from the origin. All right. So we still have that. This is going to move it away from the origin, or actually the vertex of your hyperbola. And then your h and your k shift where those asymptotes are. So let's do that. So step 1 is to draw in the asymptotes, and let's do that with a cute little color. So my asymptotes are 1 and 2. The 1 is going to be the the x, so x is 1, so we're going to go over 1, and so there's 1 asymptote this way, and y is 2, so y is going to go up 2, so I'm not going to go past here. So what happens then is this becomes your new origin in your brain, okay? You still plot the points based on this origin, but now we should end up with hyperbola like this. Now I'll show you a secret. When we graph this, and you're going to say, wait a minute, it doesn't. If your numerator is negative, it's going to flip it, and let's see what that does to it. All right, so -2n for x, and I've already picked some denominators that will keep my, or some x's that will keep my denominator divisible by 3, or 3 divisible by this number. So -2 minus 1 is -3. -3 divided by -3 is +1 plus 2 is 3. Oh, my marker's dying. We'll just have to use this one. And then 0 minus 1 is -1. -3 divided by -1 is, oh boy, here, I can't do two things at once. 0, -1, 3. -3 divided by -1 is +3 plus 2 is 5. 2 minus 1 is 1, so -3 plus 2 is -1. And 4 minus 1 is 3. -3 divided by 3 is -1 plus 2 is 1. All right, so when we plot these, remember you're plotting from the original origin, okay? Don't get confused and try to plot from your asymptotes. So -2, 3, 1, 2, 3 is up here. 0, 5, 1, 2, 3, 4, 5 is right here. 2, -1 is here. And 4, 1 is 1, 2, 3, 4, and up 1. So now because you know this is going to be a hyperbola, you know these are points that help me know where to kind of turn. And these are points that help me know where to turn on this one. And now you can look to see, so you see our original graph was in quadrants 1 and 3, and now this one is in 2 and 4. What happened is, because this numerator is negative, it flips it, okay? And so it's going to shift it around so that now our hyperbola is opposite of what it was, okay? So you can kind of know if your numerator is negative, you know where your hyperbola is going to go. And if you have that in your mind, then you know when you're plotting the points, oh yeah, I've got this right, or no. And you can see that now this has become the center, the vertex of your hyperbola. All right, so far so good. So step 1, draw the asymptotes, and then just plot some points and draw your hyperbola. All right, last type, and this is where it gets crazy. We can do this though, no problem. So now, this one is a little bit different. Now, we're not always going to have a nice, neat, where's our h and where's our k, and sometimes y equals a binomial over a binomial. In this case, you need to, the steps are still the same. You're still going to draw your asymptotes, plot points to the left and right of the vertical asymptote, and then draw a hyperbola. That's all you're going to do. But what you've got to know is you've got to know where those asymptotes are. So make sure you get these equations down. Your asymptotes are going to be, the vertical asymptote is going to be where x equals -d over c. If you don't remember that one, your vertical asymptote is where your denominator equals 0. All right? Because if you were to set this equal to 0 and solve, you're going to end up with -d divided by c, which is right here. All right, so if you forget that one you can come up with, all right? Your horizontal asymptote is where y equals, or horizontal, this is where y equals a divided by c. So your constants in front of your x terms are your horizontal asymptotes. So let's do one of those. Here we go. And what I'm going to do is I'm going to put this one right here so that we can still get our bearings here. And Oh, let's just erase the whole thing. Here we go. All right, so step one, we need to find the asymptotes. Our asymptotes are x equals negative d over c. So what is the d and the c? Do you remember where those were? So this is a, b, c, d. So negative 2 over 1. So x equals negative 2. That's one asymptote. So let's find it on here. Let's see. So x is a vertical. X equals negative 2. So here's, can you see it? Oh, I didn't test this out. There we go. All right, so there's 1. And now the horizontal asymptote is at y equals a over c. And you remember those are the coefficients of our x terms. So 3 over 1. So y equals 1. All right. So y is 1 up. So here's my horizontal asymptote. You got it? So now this is my origin right here. I'm going to circle my origin so we don't lose it in this black and red graph. So now I'm going to pick some points, and I've picked some points that will work quickly and easily already. So now we put in 3, negative 6 minus 6, and then negative 6 plus 2. So 3 times 6 is 18, negative 18 minus 6 is 18, 19, 21, 22, 24, negative 24 over negative 6 plus 2 is negative 4. So that should be positive 6. And then 3 times a negative 4. Do this on your own real quick. See if you can beat me. Negative 4 plus 2. Negative 12 minus 6, 16, 17, 18. Negative 18 over negative 2 is positive 9. And then negative 1 is negative 3 minus 6 is negative 9 over negative 1 plus 2. Negative, oh, that's 1. Yay, so that's going to be negative 9. And then 4, 3 times 4 is 12 minus 6 is 6 over 4 plus 2 is 6. 6 over 6 is 1. All right, so now we're going to plot the points. Let me find, okay. So negative 6, 6 from the origin. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 1 point. And negative 4, 9. 1, 2, 3. Oh, where's my origin? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9 is way up here. And then we've got from the origin, we've got negative 1, negative 9. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? 5, 6, 7, 8, 9. Yes. I turn into, and then 4, 1 is 1, 2, 3, 4. What did I do wrong? Because I shouldn't be on my asymptote. So I know I did something wrong. Did I put my asymptotes in the wrong direction? That's what I did. Oh my goodness. Okay, so, oh no, oh no, oh no. Oh, you know what? No, I didn't. Look, why did I get y equals 1? Looky here, looky here. Are you hollering at me the whole time? Because look, this is 3 over 1, so this should be 3, not 1. 3 over 1 is 3. So that's why. So this asymptote is at 1, 2, 3. So this asymptote is here. Were you hollering at me that whole time saying, why is your asymptote in the wrong place? What on earth are you talking about? I hope so. There we go. And that's a good way to see, oh, that's how you can know what you did wrong. So now, using those points, there's your hyperbola here and here, like that. And hopefully you have larger graph paper, and so it will be easier because it should match up just like that. Ta-da! Okay, so the biggest things are, make sure to find where your asymptotes are first. Once you find your asymptotes, just plot a couple of points, and then you're going to have a hyperbola either in these 2 quadrants or in these 2 quadrants, and they should be mirror images of each other. And if not, then you know you did some points wrong and you need to go back and you need to check them out. All right? I think you've got that. Make sure you've got these two equations for your vertical and horizontal asymptotes, and I'll see you next time.